For number 4, I'm given a problem that does not have a common denominator. The denominator for my first fraction is a 3. The denominator for my second fraction is a 5. Well, obviously they're not the same number. In order to add them, they must be the same denominator. Again, the easiest way to find a common denominator at this point in time, when I'm dealing with fairly small numbers, is simply to multiply these two denominators together to find out what that number would be. So 3 times 5 would give me a 15. 15 is a number that I can use as a denominator for both of those, because 15 is a multiple of both 3 and 5. So I can convert this 3 into a 15. It's an addition problem, so it's going to remain an addition problem. I can convert this 5 into a 15, and that's going to equal a number that's also over 15. If this one has 15 parts and this one has 15 parts, then the answer is going to have 15 parts, so I'll be able to solve this. What do I multiply the 3 by to turn it into a 15? That was a 5, wasn't it? So I multiplied the 3 by 5, which means I must multiply the 1 by 5. 1 times 5 is 5, and 3 times 5 is 15. I've converted the fraction 1 over 3 into the fraction 5 over 15. They're the same spot on a number line. If I had a number line, and here is the 0, and here is the number 1, if this number line has 3 parts, and I've got one of them, I'm right here, aren't I? If this number line instead had 15 parts, then I would have 5 of those 15 parts, and I would be right here. Because I've got 5 of the 15 parts, or I've got 1 of the 3 parts. It's the same spot on a number line, whether it's 5 over 15 or it's 1 over 3. It's the same spot on a number line. It's the same number. It's just in a different form because it was convenient for me. So the 5, to turn it into a 15, I multiplied that by 3. So since I multiplied the denominator by 3, I must multiply the numerator by 3. 1 times 3 is 3. 5 times 3 is 15. Now I have an addition problem where my denominators are the same. 5 plus 3 equals 8. My final answer is 8 over 15. For problem number 7, again we're given a fraction. It's an addition problem that does not have common denominators. It's got a little bit larger numbers here. What is going to be my common denominator of both the 5 and the 13? Well, like we've said, when we've just got smaller numbers like this, we can just multiply the two of them together. 5 times 13 equals what? Those of you that are good with your multiplication tables should know this answer. If not, you could just take your handy-dandy calculator, which you are allowed to use in this class, and multiply 5 times 13 and hit enter, and you get 65. So 65 is a good denominator. So I can convert the 13 into a 65. It's an addition problem. I can convert the 5 into a 65, and that's going to give me an answer that has 65 parts. What did I multiply the 13 by to turn it into a 65? I multiplied it by 5, didn't I? So again, I'm going to multiply it by 5. 1 times 5 is 5, and 13 times 5 gave me the 65. The 5 I multiplied by 13, so I must multiply the top and the bottom by 13. 1 times 13 is 13, and 5 times 13 gave me the 65. Now that I've got common denominators, I simply add the numerators. 5 plus 13 equals 18 over 65. Final answer, 18 over 65. Now sometimes you want to look at this and see if the number can be simplified. In this case it cannot, but you always want to look because the correct answer is simplified. The correct answer can be in fraction form, it can be an improper fraction, which we'll talk about later, but it does need to be simplified. How do I know if this number needs to be simplified or not? Well, the top number, 18, ends in an even number, so it's divisible by 2. The bottom number is not an even number, so it's not divisible by 2. The top number is divisible by 3, because 8 plus 1 equals 9. 9 is a number that's divisible by 3, but the bottom number is not. 6 plus 5 is 11. 11 is a number that's not divisible by 3. The bottom number is divisible by 5, the top number is not. What am I doing? I'm going through the prime numbers, aren't I? 2 is a prime number, 3 is a prime number, 5 is a prime number. What's the next prime number? 7. Well, this is not divisible by 7. The next prime number is 11. They're not divisible by 11. Then 13, well obviously that's not going to work because 13 certainly can't go into 18 twice. So I've gone through all the prime numbers that could possibly have worked, and they don't. So this number is as simplified as it gets. Final answer, 18 over 65. For number 10, they're having us deal with a little bit larger numbers. We have 14 over 17 minus 6 over 34. So we've gone to a subtraction problem instead of an addition problem. And we also have a much larger set of numbers in our denominator. Now, what we've been doing is just multiplying these two denominators together to get our common denominators. And we're allowed to use a calculator in this class, obviously. So we could take our calculator, so we could take the 17 times the 34, and you could get 578 as your common denominator. So I can take this and make my common denominator of 578 minus something over 578 equals something over 578. If you do that and you simplify when you're done, you will get the correct answer. If you did this, that's fine. There's been many times when I looked at these and I did not clearly see or quickly see a better common denominator, or what we call the least common multiple, which we're going to study a little bit later in the lesson. Not in this lesson, but a future lesson actually, up in the 40s. So if you do this, you will get the right answer, but you'll be dealing with large numbers. If you're good with your multiplication tables, you may have spotted that 2 times 17 would be 34. So 34 is a multiple of 17. I can convert the 17 into a 34 by simply multiplying it by 2, and that would give me a much smaller denominator to work with. So let's do it that way. But if you did it this way, you would still come up with the right answer. So since I can multiply the 17 times 2 and it will become a 34, then I also multiply the 14 by 2. 2 times 14 gives me 28. Again, in this process, if you need to use a calculator, you may. The 34, I don't have to change at all, do I? It's a subtraction problem. The 34 is already in the right form, so I just leave it exactly the way it is. The 6 over 34 comes down, stays as 16 over 34. So now I've got an answer that's going to be over 34, and I simply have the 28 minus the 6, which should give me a 22, if I'm doing the math in my head correctly. Now, but remember we said you always want to ask yourself, do you need to simplify? If this is the answer you were left with, it is a technically correct answer, but not an actually correct answer, because it's not simplified. How does it need to be simplified? Well, the 22 is an even number, which means it's divisible by 2, and the 34 is also an even number, which can be divided by 2. If you can divide a prime number into both the numerator and the denominator, then it's not simplified yet. So if I divide the top by 2, that's going to give me 2 goes into 22 11 times. And if I divide the 34 by 2, it's going to take me back to that original 17, isn't it? So the correct answer is 11 over 17. That's the only thing that's correct. If I was giving you a quiz, Mom and Dad, and they gave me an answer of 22 over 34, I might give them a couple of points out of there's usually 5 points on a quiz. I might give them 1 or 2 of the points for getting the problem close, but it's not correct. This is correct.